Hi, Murli, hi. Is the audio and video is clear? Murli, audio and video clear unda? Hi, Suhas, hi. Ram Sheikh, hi. Hi, Sheikh, hi. Is the audio and the video is clear? Right. Done. Right. Now we'll wait for the 2 minutes so that the rest other comes. So after that we'll start the lecture. Right. Okay, fine. Ramuddin, Ramuddin. Yes. Hi, Aramuddin, hi. Right. Now, now, uh, right. We'll wait for the few minutes so that the rest other comes. We'll start the lecture. Mm, right. Okay. Just a few minutes. Just few minutes. Now, the last class till where we done? The last class we have done up to the chemical property, right? Sorry, physical properties. No, preparations of the which one? Preparations of the alcohols we have did. Then after that, how the functions of the Grignard reagent. That all we have seen. Now today we are going to see the physical property as well as after the physical property. Next we are going to see the chemical properties of alcohols. Then after that the reactions. That all we are going to see in this lecture. Okay, fine. Now we'll start the lecture. I hope the rest all are as came. Fine. Okay, right. No, some in my mm, now here in the last class we have studied about the which one? We have studied about the preparations of the no. We have studied about the preparations of the alcohol. Now, in that preparations of the alcohols, we have seen how the alcohols are prepared from the SN1, SN2 reaction. Then after that, we have seen the Which one? With the reducing agents, how to prepare the secondary alcohol, how to prepare the which one? Primary alcohol. Clear? Then after that we have seen some reaction. Now we are going to see the physical properties. Next we are going to see the physical properties. Physical properties of alcohols. Clear? Now, physical properties of the alcohols are also very important. Now, in this physical properties of the alcohols, the very first key point is alcohols having higher boiling points. First of all, the alcohols are having the higher boiling points than the hydrocarbons, comma, ethers, comma, aldehyde, comma, ketones. Can anyone say why? What is the reason for this one? What is the reason for the alcohols having the higher boiling point than the aldehydes, ketones, ethers, and hydrocarbons? Can anyone say? Can anyone say me the reason why? What is the reason behind it? Because the alcohols are having the higher boiling point. Can anyone say me the reason? Can anyone? If you know, say me the answer. If not, give me the question mark. If you know the answer, say me. If not, give me the question mark so that I can proceed. Anyone know the reason? Right. Okay, done. See, why the alcohols are having the higher boiling point than the rest of the, because these are the statement based questions also they are asking. Why? Because you know alcohol very fastly what it will do? It forms hydrogen bonding. Very fastly it forms hydrogen bond. Due to that hydrogen bonding or due to that intramolecular hydrogen bonding, its boiling point has been increased. This is very key point you have to remember. Due to the hydrogen bonding, alcohol's boiling point will be increases. Clear? Now, next. Boiling point, next point you have to remember. Boiling points of alcohols, boiling points of the alcohols increases with the molecular weight. As the molecular weight increases, what happens? Now, due to the van der Waals force, molecular weight, and the next due to that molecular weight is increasing, or due to the van der Waals force also, its a boiling point increases. Now you have to say me among the, I will write the structures. One, among the given one which is having the higher boiling point, you have to say me. Shh. Hi Pranit, hi. Now you say me among the 1, 2, 3, 4 which is having a higher boiling point. Among the 1, 2, 3, 4 which is having the higher boiling point. Among the 1, 2, 3, 4 which is having the higher boiling point. Which is having the higher boiling point. Among the 1, 2. Order, boiling point order. Boiling point order. Order of the boiling point. Hi Shubham, hi. No. 1, 2, 3, 4 is a order, right? Now 1, 2, 3, 4 is a order. Clear? Now in this manner we can prepare the which one? This is a boiling point order for the alcohols. Right. If suppose next Now next I will give you this one, N-butyl alcohol. Second one, isobutyl alcohol. Next, third one, neobutyl alcohol. Okay, among the 1, 2, 3, which is having the higher boiling point and order? Which is having the higher boiling point and order? Which is having the higher boiling point and order? Which is having the higher boiling point and order? Ah, yes. Because reason due to the surface area. Due to the surface area. Now, surface area is high, branching increases, boiling point decreases. Okay, branching increases, boiling point decreases. Right. Next we'll move to the which one? Chemical properties. Next we'll move to the chemical properties. Now, in the chemical properties of the alcohol, now this hydroxyl group in alcohol, this hydroxyl group in alcohol is very reactive. Is a very reactive. Clear? And these characteristics of the reactions of the alcohols of the number of which. Now, Captain America, good evening, good evening, good evening. Now, they see the reaction of the hydroxyl group. This reaction of the hydroxyl group now consists of either breakage of C bond O or breakage of OH. So depending upon the breakage, we have to decide the reactivity. Clear? Now this hydroxyl group reactivity order we have to depend upon the which one, depending upon the breakage. If suppose this is a hydroxyl group, it is attached to the carbon. Next, if this the same hydroxyl group is attached to the carbon, done. If suppose here it is CH3, here it is a CH3, here it is a CH3. Okay, now this one CH3, now CH3, now this is a CH3. If the two reactions, if they are given depending upon the breakage, no, I had Captain America, I had my lunch, sorry, I had my dinner, sorry, and I started the live just 9:30. 9:30 only I started the live. Right. Now listen. Now depending upon the breaking of the bond, now we have to see the reaction. See, if the bond has been broken between this carbon and oxygen, if the bond has broken between the carbon and oxygen, what it will get? Carbocation will get. So then if the bond has been broken in between the oxygen and the hydrogen, then we'll get the oxide ion, alkoxide ion. This is a alkoxide ion. Now, can anyone say me the stability order of this carbocation, and what is the stability order for this alkoxide ion? What is the stability order for this alkoxide ion and what is the stability order for carbocation? Can anyone say me the order? What is the stability order of this carbocation and what is the stability order of this alkoxide ion? Now you can see, if you break the bond between this carbon and oxygen, we are getting the carbocation. If you break the bond between this oxygen and hydrogen, we are getting the alkoxide ion. 3 degree, 2 degree, 1 degree for carbocation, and for the alkoxide ion, reverse for the alkoxide ion, because this carbon ion bearing the negative charge due to the plus I groups of this methyl group, what it will do, it will decrease its ability. Due to the decreasing of its ability, now its stability order will be 1 degree greater than, 2 degree greater than, 3 degree. Clear? Now depending upon the breaking of the bond, we have to decide the reactivity of the alcohol. So reactivity of the alcohols will play very important role. If the bond has broken between the oxygen and nitrogen, stability order will be 1 degree, 2 degree and 3 degree. If the bond has broken between the carbon and oxygen, the stability order is 3 degree, 2 degree and the 1 degree. Clear? Done. This is a one very important point you have to remember. Now we'll see the, depending upon the bond breaking, now we are going to see the acidic natures of alcohol. Acidic nature of alcohols. Okay, in the acidic natures of the alcohols, you have to be very careful with the acidic nature of the alcohols. What they are asking, based on that acidic nature, we have to clear. Now we have to decide. I will write the molecules. Now you have to say me the acidic nature of the alcohols. First one, if they ask what is the acidic nature, here first of all, if suppose if they have given the methanol and ethanol, if they have given, okay, done. Next, if suppose 2 degree alcohol if they have given, okay, done. Now they will ask you which among the following is a strong acid. First of all, if any acidic nature questions if they are asking, first thing you have to be think in your mind that this H plus will be given to the solution and we have to stabilize this alkoxide ion. Now after the H plus, if it is given to the solution, now this alkoxide ions will get the negative charge, right? This alkoxide ions will get this negative charge in this manner. Now when these alkoxide ions are getting negative charge, now this is a carbon ion, right? This is a carbon ion. Now this is stability of conjugate acids. These are the acids after loss of hydrogen, we call it as a conjugate acid, right? Now this conjugate stability of this conjugate acids will be stabilized by minus I groups increases stability, minus I groups increases stability, plus I groups decreases stability. This is the one very key point you have to remember for the acidic strength of the alcohol. Done. If the hydrogen given, this conjugate acids are there. This conjugate acids will be stabilized by the minus I groups and decreased by the plus I groups. Why? As the plus I groups increases, now negative charge on this oxygen will be increased and it will become more destabilized. Right? Now I will write the some compounds here. Now you have to say me which is a more acidic here. Now among the 1 and 2, which is more acidic? Among the 1 and 2, which is more acidic? Among the 1 and 2, which is more acidic? 2. Why? Reason? May I know reason? But minus I effect of NO2 is greater than Cn, right? Minus I effect of the NO2 is greater than Cn. How you have chosen the yes, inductive effect Inductive effect is distance dependent. Inductive effect is distance dependent. As the minus I is nearer to the alkoxide ion, minus I is nearer. So that's the reason 2 is the answer. 2 is a more acidic. Okay. You have to be very careful with this one. Now, next. Next. Here the methyl alcohol and the H2O. Methyl alcohol and the H2O if they have given. And the ethyl alcohol they have given. C2H5OH. Now order. Can anyone say me the order? 1, 2, 3. Vishal Raj, your class has completed. You have came to the second year's class. మీ క్లాస్ అయిపోయింది నాన్న. విశాల్ రాజ్ మీ క్లాస్ అయిపోయింది. 213. 213. Now, but actually experimentally we got to know that methyl alcohol is more acidic than the H2O. The H2O is more acidic than the ethyl alcohol. This is the order. This is the order. Actually, this is the order. No. Order is 1 greater than 2 greater than 3. H2O and ethyl alcohol. H2O and the ethyl alcohol, H2O is higher. But methyl alcohol and the H2O, methyl alcohol is higher. So you have to be very careful with this one. Now, can anyone say me nucleophilicity order for this one? Can anyone say me the nucleophilicity order? Can anyone say me the nucleophilicity order? Can anyone say me the nucleophilicity order for it? Can anyone say me among those three, what are the nucleophilicity order? Yes, reverse. Strong acids, conjugate bases are the what? Poor nucleophiles. Then the order will be E, OH minus and the OH minus, and the last one will be the OMe. Clear? OMe. Right. These are the nucleophilic strength order. Now, next one. Now the next very important we are going to see the oxidizing agent table. No. Here all the cases nucleophilicity sites are same, right? Then what happened? In all the cases nucleophilicity sites same. Acids conjugate bases are the weak nucleophiles, right? Weak acid conjugate bases are the strong. This only order, reverse only, correct only. You have said correct only. EOT, this conjugate bases are the nucleophiles. This is only correct. Now, next we'll move to the which one? Oxidizing agents table. This is also very important. Now this is very important, and by this we can expect the direct questions. From here we can expect the direct questions. Now here if you remember this table, it will be helpful for us in the which one? In the alcohols, phenols. Sorry, not in the alcohols, phenols. We can useful for us in the carbonyl compounds also. Oxidizing reagent table. So first one is a reagent. Then second one, when it has reacted with the 1 degree alcohol. Second, when he has reacted with the 2 degree alcohol. When he has reacted with the 3 degree alcohol. What it will happen? Now we'll see. First one, KMnO4. KMnO4 is a strong oxidizing agent. Now, if suppose the 1 degree alcohol there, what it will do? With the 1 degree alcohol, what it will do? Can anyone? Second one is a K2Cr2O7. K2Cr2O7. Can anyone say me what it will do? Can anyone say me what it will do? Next, third one will be the KMnO4 upon 1 degree alcohol. What is the product we will get? KMnO4 upon 1 degree alcohol, KMnO4 upon 2 degree alcohol, KMnO4 upon 3 degree alcohol. What are the products we will get? I am asking. You don't know? Ayya. Oh my god. You guys forgot. No one else. No one else. KMnO4 upon 1 degree alcohol, it will directly convert into the carboxylic acid. KMnO4 upon 2 degree alcohol, it will be converted into ketone. Now KMnO4 upon 3 degree alcohol, no reaction. Now the Jones reagent will be the H2CrO4 plus acetone. H2CrO4. Clear? KMnO4 when it is reacting with the 1 degree alcohol, carboxylic acid, ketone and the 3 degree no reaction. Now K2Cr2O7 is also a strong reducing agent, strong oxidizing agent. It will directly convert into the carboxylic acid, ketone and no reaction. Then next one, Jones reagent. This is a Jones reagent. In this Jones reagent also, now if suppose up to the 70 degree if they have given, then it will stop the reaction at aldehyde. Still, if the temperature high they have given, directly it will convert into the carboxylic acid. Then it will convert into the ketone. Clear? And 3 degree alcohol, no reaction. 3 degree alcohol, no reaction. Next one. Next one. The fourth reagent we are having the what one? Collins reagent. Collins reagent means Cr2O3 in the presence of pyridine. In the presence of pyridine base. Now this is a Collins reagent. Now in this Collins reagent, 1 degree alcohol will be converted into aldehyde. 2 degree alcohol will be converted into ketone. 3 degree, no reaction. Now fifth one. Fifth one we are having the PCC. What is the PCC? Cr2O3 plus HCl and pyridine. Now pyridine is also mild oxidizing agent. It will stop the reaction at 1 degree alcohol at the aldehyde stage. And the 2 degree it will be converted to ketone and 3 degree no reaction. Alright. Next. Sixth one we are having the Cl2 oxidizing agent. It will also mild oxidizing agent. It will convert into the same. Next, copper and the high heat. Copper or copper at high heat. Copper at high heat also it will convert into the which one? Aldehyde ketone, but it will react with the 3 degree alcohol. 3 degree alcohol it will react and it will convert into the alkene. This is also one very important you have to remember. Done? Next. This table is clear, right? Any confusions? Next, very important one you have to remember, MnO2 is a selectively oxidizing agent. Selectively oxidize. This MnO2 is a one selectively oxidizing agent. It will selectively oxidize the which one? Allyl and benzyl alcohols Allyl and the which one? Benzyl alcohols. Allyl and the benzyl alcohols. Allyl and the benzyl alcohol, 1 degree alcohol to the aldehyde. Clear? 1 degree alcohol to the aldehyde. Only allyl and the benzyl alcohols only will be oxidized by the MnO2. You have to be very careful. Clear? Now the table has been clear, right? Now I will write the questions. Now you have to say me the answer. Okay? Now, here, two reagents they have given. One is KMnO4, one is a Cu at high heating. Now, what is the product in one? What is the product in one and what is the product in two? What is the product in one and what is the product in two? Next one. Now, in the second reaction, first one no reaction. Yes, good. First one is a no reaction. Second one. Second one. Say first one is no reaction. Okay. Second one then. Second one. Second one will be the 2-methyl prop-1-ene. Yes, good. 2-methyl prop-1-ene. Yes, good, good, good. 2-methyl prop-1-ene. Right, right, right. Good, good, good. Now, next. Now you have to say me but 2 in but 2 in 1 ore. But 2 in 1 ore. But 2 in 1 ore upon which oxidizing agent gives but 2 in 1 oic acid. Now what are the best, which is the best oxidizing agent to give this one? But 2 in 1 ore upon what reducing upon what oxidizing agent? What is the best oxidizing agent to give this one? What is the best oxidizing agent to give this one? What is the best oxidizing agent? Nana, my dear Praneeth, నేను ఇక్కడ ఏమిచ్చిన బ్యూట్ 2 in 1 ol ఇచ్చిన బ్యూట్ 2 in 1. How come the KMnO4 will be react with the diene? KMnO4 will react with this which one? Alkene carbon, and it will give you the diol, right? It will give you the diol, right? How come the KMnO4 K2Cr2O7 will be react? How come the K2Cr2O7 KMnO4 will be reacted? But the product name I was given the but 2 in 1 oic acid, right? But 2 in 1 oic acid means whatever the KMnO4 and the K2Cr2O7 and the HNO3s are not the best suitable reagents. Now only the best suitable reagents is only the Jones reagent. Only the Jones reagent is best. Only the Jones reagent is best. The best reagent is Jones reagent. Clear? Done? Right. Okay, fine. Now next one. Next one. Next one. Next one you write. I will write the UPSC. Now you have to say me the which is the best suitable reducing agent it is required for it. 1 phenyl, 1 phenyl, ethane, 1 ol converted into acetophenol. Now what is the best oxidizing agent? What is the best oxidizing agent? What is the best oxidizing agent? 1 phenyl, ethane, 1 ol. Upon what is the best oxidizing agent to convert into the acetophenol? To convert into the acetophenol. Can anyone? Other than KMnO4, K2Cr2O7 and any other? John's reagent, okay. These all are best only. Because K2Cr2O7 and the KMnO4. Now you say me. Okay. MnO2 is also best. Now you say me 1 phenyl or else benzyl alcohol. Now you say me benzyl alcohol to give benzaldehyde. Best oxidizing agent. Benzyl alcohol converted into the benzaldehyde. Best oxidizing agent. What is a selective oxidizing agent? Amar, rest any other who are in the live, try to give me the answer. Only the one Pranit is giving the answers. Rest others, you are also there, right? Try to give me the answers. Benzyl alcohol is converting into the benzaldehyde. What is the best oxidizing agent? What is the best oxidizing agent? Now try to give me the answer. If you know, try to say me. If not, try to say me. If not, give me the question mark. I will say. No. See, benzyl alcohol upon what is the best oxidizing agent to convert into benzaldehyde. No. The best oxidizing agent to convert benzyl alcohol into the benzaldehyde is MnO2. MnO2 is the best reagent that it will convert into the which one? Benzyl alcohol into the which one? Benzaldehyde. Clear? Is it clear? Now next. I hope it is clear for everyone. I think so. Next we'll move to the now right. Next we'll see some reactions of the alcohol. Now some reactions of the alcohol. Already we have studied some reactions of the alcohol. Dehydration of alcohols. First one is the dehydrations of the alcohols. In the dehydrations of the alcohols, now we have to know some dehydrating reagents. dehydrating reagents. What are the dehydrating reagents? First one, Al2O3 upon heating. Next, P2O5 upon heating. Next, H2SO4 at 170 degrees and heating. These are the some dehydrating reagents you have to remember. Clear? If you remember this dehydrating reagents. Now, here next H3PO4 also. H3PO4 upon heating. These also some dehydrating agents. Now, may I know if I take this one, okay, 3-phenyl butane 1-ol upon concentrated H2SO4 at 170 degrees Celsius and heating if they are given. May I know what is the product IUPAC name? What is the product IUPAC name? And which is the mechanism involved in it? What is the product IUPAC name and which is the mechanism involved in it? What is the product IUPAC name and which is the mechanism involved in it? Can anyone? E2 and product name? E2 and the product name? E2. 3-methyl but 1-ena. Yes. Now the product, actually the reaction involved in is, no. That Pranit, you have said the mechanism wrong. Mechanism is not E2. Mechanism it will follow. You are saying it is E2 but not E2. Product you have said correct only, but mechanism is not E2. Once you cross check. E1. It is E1 because first the oxonium ion will form, right? First, what it will form? Oxonium ion it will form. It will form the oxonium ion. After the forming the oxonium ion, now as a H2O it will be eliminated, we know. Then after that we'll get the 1 degree carbocation. Now we know 1,2 hydrate transfer will take place. When the 1,2 hydrate transfer takes place, again we got the 2 degree carbocation. After getting the 2 degree carbocation, again we are having the hydrate. Again we'll do the 1,2 hydrate transfer. Then after that we'll get the positive charge. Then after getting the positive charge, we know the Sedgwick alkene is a more major. Sedgwick alkene is a more major. So how you got the 3-methyl but 1-ene? No. How come you got the 3-methyl but 1-ene? This is 1, 2, 3, 4, right? So 2-methyl, we have to cross check the IUPAC. 3-methyl but 1-ene, right? 2-methyl but 1-ene. This is not the 3-methyl but 1-ene. This is a 2-methyl but 1-ene. Why you have not rearranged? You have to rearrange, right? Why you are forgetting? Carbocation stability order. No, I said you right. Alkali halides. Alkali halides, if it is present, readily it will undergo E2. Alcohols, if it is present in the concentrated H2SO4, even it will go. Even readily it will undergo. So you have to be very careful with this one. 2-in. Yes. Right. Now I will write the some reactions. Now you have to say me. 1 upon H plus heating. Second one, H plus heating. Now say me. What is the product name and what is the product name? First one, what is the product name? Second one, what is the product name? First one, what is the product name? Second one, what is the product name? One methyl cyclopentane, one ola. My dear Praneeth, somewhere you are doing wrong. Somewhere you are doing wrong. First one not correct. First one is not the correct. Methyl cyclopentene. Ah, right. Good, Nana. So was good. Actually, the answer is this one. The answer is 1-methyl cyclopentene. Methyl cyclopentene. Second one. Second one. Second one. What is the answer? Second one. What is the answer? For the second one? Methyl cyclohexene, right? Yes. A ring expansion will be takes place. Now the answer will be the methyl cyclohexene. Methyl cyclohexene. Right? Right. Now, next one, rate of dehydration. Rate of dehydration. In which case, the rate of dehydration will be happen very fastly. You have to say it. Now, rate of dehydration in 1, 2, 3. Among the 1, 2, 3, now what is the rate of dehydration? What is the rate of dehydration in the 1, 2, 3? What is the rate of dehydration in the 1, 2, 3? 1, 2, 3, because it is more stable carbocation. 2 and 3. More the resonance, more will be the stability of the carbocation we get. So it will be the more active branch. No, right. Next one will see the reaction with no ditrihydric alcohols. Reaction with ditrihydric alcohols. Now, here the di and trihydric alcohols, first we'll go with the ethylene glycol. This is a ethylene glycol. Now, in this ethylene glycol, now if you take the sodium, now what it will do, sodium, due to the ethylene glycol, when it has reacted with the sodium, it will produce the H2 gas. Now, if the substrate is weak, and here in the byproduct, if any strong acid, if it is a weak acid and if it is producing the strong acid, no reaction will take place. Okay, if suppose substrate is strong and if it is producing the weak acid, then it will be happen. That you have to be very careful, you have to be remember. Okay, next one, sodium amide, if they have given sodium amide, if they have given also, it will be react with the same ONA plus H2 gas, right? Next one, if suppose the HCl excess if they are given, and now here it will be the chlorine and the chlorine. Done. Now this is a one reaction with the ethylene glycol. Suppose the ethylene glycol and the HI excess if they are given, what is the product we'll get? Now we'll see. Ethylene glycol and the oxygen excess if they are given. This is the ethylene glycol and the HI excess if they are given. Done. Now when the HI excess if they are given, now we know oxygens will attack the H plus will be plenty in the solution. Oxygens will attack the H plus which is present plenty in the solution, so that it will give you the iodines. Done. Then after that, this iodines, due to the bulky rays, now you can see due to the bulky of this iodines, it is unstable. Due to that unstable, what it will happen? Now its bond will be broken. Its bond will be broken and it will be converted into the which one? Alkene. Again it will be converted into the alkene. After converting into the alkene, HI excess we are having, right? Here also one H plus and the I minus will be there. H plus and I minus will be there. Now if any of both are symmetry, any of the carbons, the pi bond can be shifted. Now by that we'll get the one is CH3, one it will get the CH2I. One it will get the CH2I. Is it clear? Done? No. Right. HI excess if they are given, now the ethyl iodide is a stable product. You have to be very careful with this type of the products. They are stressing with this type of the questions only. Next, if suppose again the ethylene glycol they have given and PI3 if they have given, PI3, then here also same, again the elimination of the OH will take place and the iodine will form. Because these two iodines are unstable due to the high size, then again it will convert into the alkene. Maybe for this question he has said the resonance. Akshit, for this question he has said the resonance. For this question, the rate of dehydration is happening in which one? 1, 2, 3 means I asked him the reason. He has said the resonance here. It is for you. Okay. No, I think it's no. Next, if suppose again the ethylene glycol if they are given and the H2SO4 if they are given, Mithu. Okay. Now upon heating, now what it will happen? Here the main product we will get the, if the ethylene glycol upon H2SO4 if they are given, we will get the 1,4 dioxane you will get. This is very important. Now you have to be very careful. Now next one, if suppose the glycerol they have given, if they have given and HI excess if they have given, what are the products? Now we have to see. With the ethylene glycol it has completed. Now we'll see with the glycerol. Now with the glycerol. Now glycerol in the presence of HI excess. Glycerol in the presence of HI excess, we know all the OH as a H2O it will be eliminated. Now in this manner the 3 iodines will get. Clear? Oxonium ions it will be eliminated and the iodines will be added. 3 iodines. Now we know iodines adjacent to 2 iodines are unstable. Now the elimination of the I2 will take place and it will give you the one alkene and the one iodine here, right? Here it is a CH2 and it will get the I. Then after that again excess of HI we are having the solution. Again what it will happen? Again here the HI will be acted. Here the HI, here the iodine, and here the iodine will form, and here it is a CH3. Again the two adjacent iodines are unstable. Again it will form the CH3. Again it will form the CH3. Again we are having the HI excess in the solution. Then it will form the 2-iodopropane. When the glycerol they have given, you have to be very careful with the glycerol. Whenever the glycerol they have given, you have to be very careful with the glycerol with the HI excess if they have given. Now 2-iodopropane is the answer, right? Now if suppose glycerol they have given and PI3 if they have given, may I know the IUPAC name of this product? May I know the IUPAC name of this product? May I know the IUPAC of this product? May I know the IUPAC of this product? If the glycerol and the PI3 if they have given, may I know the what is the IUPAC name of the product? What is the IUPAC name of this product? This one. For this one, when the glycerol is reacting with the PI3, what is the IUPAC name of the propene? How come propene? No. Now the answer will be first whenever the PI3 if they have given. No. Here the first three iodines will be formed. All the PI3 is a what? It will be dehydrating agent. Now it will eliminate the OH. Iodopropene. Correct. Right. Now all the H2Os will be eliminated. Now we'll get the iodine. Now we know the two adjacent iodines are unstable. Now as the iodine's I2 gas it will be eliminated. Now we'll get the alkene here. After getting the alkene here, now we are having the iodine. Right? Clear? Now here in this manner you will get. Next you have to say me, if the suppose the glycerol they have given. Glycerol upon H2SO4 if they have given. What is the product you will get? Glycerol upon H2O2. What is the product you will get? Glycerol upon H2O2. What is the product you will get? Glycerol upon H2O2. What is the product you will get? If you know the answer, say me. If not, give me the question mark. If you know the answer, say me. If not, give me the question mark. Right. Here, glycerol upon H2O2, what did it do? H2O2, it will give you the acrolein. You know the acrolein, right? Now this is a acrolein. Now acrolein is a very important Now we'll see the mechanism how it will give. Prophenol, yes. Now how it will give the acrolein? Now we'll see. Now this is a OH, glycerol, this is a OH, and this is a OH. Now from the concentrated H2SO4 will get the which one? Proton. Now when it is readily getting the proton, now this proton it will be readily abstracted by the middle oxygen. Now what it will happen as a H2O, it will be eliminated. After H2O it is eliminated, here it is generating the which degree carbocation? It is generating the 2 degree carbocation which is stable. And the rest others are 1 degree carbocation. Then after that, when this 2 degree carbocation it has generated, now here it is a OH. Clear? Again to this carbocation to stabilize. Again to carbocation to stabilize. Now NCERT for the mole concept, NCERT for NEET or JEE, for the NEET or JEE, here the to stabilize this carbocation 1,2 hydrate transfer we have to make, because if you make the 1,2 hydrate shift, 2 degree alcohol will become the what? 1 degree carbocation is stabilizing the mesomeric effect of the H. Now this oxygen NEET. For the NEET, reading of the NCERT is first priority. You can read, but after the reading of the NCERT, you have to do the more number of questions to understand the mole concept application. By reading the NCERT itself, it will not give you the 100% efficiency to get the more marks. So after reading the NCERT, you have to solve the more number of questions from the any other question bank or any other modules or anything. Okay, right. Then after that what it will happen? Now this oxygen, its lone pair of electron will stabilize this positive charge. Then after when the oxygen's lone pair of electrons are stabilizing this positive charge, then what it will get? Here the CH2, here it will get the C double bond, and here it is a H, because oxygen positive charge is stabilizing by this proton. Done. Then after that, now the practical chemistry also, instead of reading from the what? Now here the elimination of the H2O takes place. Instead of reading from the NCERT, better you try to read it from the any reference books. Physical chemistry, sticking to the NCERT is good only, but the more the number of questions you have to do, more the number of PYQs you have to do, more the number of PYQs you do, more you will get. For the physical chemistry, more the PYQs you do, more you will get. Anthony, okay? Studying of the NCERT is good only. After studying of the NCERT, more the number of PYQs you have to solve. Now by here, this is about the chemical property and the reactions of the which one? Phenols. Now the one who are in the live, once you say me hi. Okay, Anthony, okay, fine. The one who are in the live, once you say me hi. The one who are in the live, once you say me hi. Nana, okay, Praneeth, any other? Other than Praneeth, any other are there? Suhas, okay, fine. James Anthony, hi. Nana, now by this, the preparations of the alcohols and the chemical properties, now the reactions of with the trihydric alcohols also, I have finished. Now today, due to some reasons, I was ending the live very fastly. I was ending the class. I was stopping the class here. Tomorrow we'll start the preparations of the alkene and the chemical properties of the preparations of the phenol and the chemical properties of the phenol. Tomorrow we will finish and we'll see the which one, how to identify the alcohols and how to identify the phenols. Clear? Now tomorrow the class timing will be, I will post the class timing and I will schedule the live once you cross check over there. Okay? Okay, fine, Nana. We'll see you tomorrow. Today actually due to some reasons I was ending the class very fastly. Okay, fine. Tomorrow we'll see about the phenols. Okay, Nana. Bye bye. See you tomorrow. Any other in the live? Good night. Good night. Any other in the live? Should I stop the live? Right. Right. Good night.